We thank God for yet another day to meet and continue with our maths lesson. Still, don't forget to like, subscribe, and share. The name of the channel is Maths Clinic. Maths Clinic. Maths Clinic. All right. In today's lesson, we'll be looking at factorization. But this is factorization 1. It means there will be series of lesson videos on other forms of factorization of algebraic expressions. So quickly, we are to factorize completely the following expressions. So we have ax plus bx, 15p minus 27pq, and lastly 18pr squared plus 6pqr. All right, so without wasting much time, let's take our first question. Ax plus bx. How do we simplify simple factorization questions involving two algebraic expressions? The only thing to look out for here is a common factor, a number or a variable which is common in both terms. So looking at the first question, what is a common letter or variable? We can say it is x because this has x, this also has an x. So the x comes out quickly and we open our bracket and write the remaining terms in it. So the remaining terms, you have a, not forgetting the sign here, plus b. So by factorization, our answer becomes x into bracket a plus b. So if you want to expand, you are going to multiply this common factor by all the terms in the bracket. So by a at the same time and by b. So x times a gives us ax plus b times x gives us bx. So we can see that we are correct. All right, let's go to our next question where we have 15p minus 27pq. 15p minus 27pq. Okay, so the rule is to look out for the common factor or factors, be it a variable or a number. So when we take the variables, we can say p is common because p is here, p is also here. And what are the numbers involved? We have 15 and 27. So what common factor can divide both 15 and 27? Yes, you had it right. The answer is 3. So it means 3 is a common factor and p is also another common factor. So they come out of the brackets. So what is left? We already have p outside, but there is 15. So 3 times 5 will give 15 minus 3 and 27. So 3 times 9 will give us 27. And because p is here and it's already here, we are not going to repeat it unless it is squared. All right. But q is here and q is not here, so q can also come. So finally, our answer becomes 3p into bracket 5 minus 9q. So you can verify your answer by multiplying the common factor by all the terms in the bracket. So 3p times 5 gives us 15p minus 3p times 9q gives us 27pq as was given in the original question. All right, let's move on to our last question. We have 18pr squared plus 6pqr. 18pr squared plus 6pqr. I hope you remember the steps. What is the first thing to do? Yes, we have to bring out the common factors, be it the letters or variables or the numbers. So when we take the numbers, we have 6 and 18. So quickly we can say 6 is a factor of 18. So 6 can come out. There is p here, there is p here. P can equally come out. This r is squared, and there's also another r here. So r is also a common factor. There is q here, but there is no q here. So q cannot be a common factor. So what will be left in the bracket? There is 6 outside. So 6 times what is giving us 18? 6 times 3. And the p is only 1, which is already outside. So p can't come. Now r squared, and there is r here. So what do we need? Another r to make it squared. Plus, now 6 is here, 6 is already here, so there is no need to write it again. P is here, P is here. R is here, R is here, but Q is here, but Q cannot be found here. So Q can also come. So by factorization, our final answer becomes 6PR into brackets 3R plus Q. So by expansion, we multiply the common factor by each of the terms in the bracket. So this gives us 6 times 3 gives us 18. P, R and R gives us R squared plus 6PR Q. I hope you are thinking of bringing 1 here. Yes, as its coefficient. But since it's not significant, we don't write it. All right, thank you very much, and see you again in our next lesson video.